Oh, hello everyone. Didn't see you there. So, welcome to this new video. In today's video, we are going to look at a new, different company from the quantum technology space. So, quantum computing, quantum communication, and quantum sensing. And who can guess which company it is? Okay, right. Here we are at the company website, and the company that we're looking at today is Q-CTRL. What does Q-CTRL do? Let's figure it out together. So here it says achieving quantum advantage in navigation. So we will learn more about that in a second. But here it says make quantum technology useful. Infrastructure software to power the quantum future. And then there's a video here. Here you see a couple of company labels. Some of them we've probably already looked at by the time that this video is getting published. So we see Alice & Bob, which is a quantum computing provider. We see IonQ, we see Rigetti. There are some universities like the Imperial College in London, Northwestern University. We have IBM Quantum, Atom Computing, and Chalmers, probably University, right? Okay. Then we have the Opal suite, products to help you achieve quantum advantage. Okay, so what do we have here? We have quantum computing and quantum navigation on these two sides. So these are probably the things that we want to look at here from, I guess, a software point of view, because we have the hardware platforms listed up there above. So what does it say? The most powerful AI-powered infrastructure software to make quantum computing useful to your organization. So it's really about creating access, probably lowering the access barriers for organizations to work with quantum computing. And then on the other side, we see the world's first and only quantum navigation solution proven to outperform GPS in the toughest environments. So this is also something that we've seen before with quantum sensing companies. It's about using this for navigation in areas where you might not have access, for example, to GPS, or in applications which also have to be able to function without GPS. Then we see Black Opal, the learning quantum computing, Fire Opal, run quantum computing algorithms, Boulder Opal, quantum computing, build quantum computers, and Ironstone Opal, navigate without GPS. And I guess we will learn about these things a little later, but now we scroll down. Powering real-world quantum outcomes. So these are now about the areas, the verticals where this is being used. We see biotechnology, cybersecurity, defense, enterprise, finance, and logistics. Here we see, I guess, what the solution is about. So pioneering AI-powered quantum infrastructure software. So software, as already assumed before. Quantum infrastructure software transforms bare metal quantum processors into useful computational tools. So bare metal refers to also what you have in nowadays silicon and compute technology. So basically the lowest, like the chip level, and what comes up above that. And here it says this infrastructure basically gets to the application layer of things, I would assume. Our technology unleashes the hidden performance inside of the most powerful computers so you can achieve more. And here we see the stack, I guess. So what do we have here? We have the physical qubit hardware, which are these systems that we saw above, like ion traps, superconducting systems, whatever. You have here the so-called quantum firmware, the hardware-aware quantum compiler. So essentially you start with your qubit. You have to somehow control it. There are some controlling mechanisms to do that, like electrical impulses, optical laser pulses, whatever. Then you have a compiler, which basically takes the idea of your algorithm and translates it into what actually the hardware level has to do to, for example, perform a specific gate on a qubit. And it says here hardware aware, as in certain platforms have certain types of gates, and sometimes for example, if you look at superconducting qubits, not every qubit is coupled with each other, but like due to the layout that you chose, you might have specific qubits coupling to others, and this has to be somewhere encoded in some level of this whole stack, and this is happening here in the compiler. Then you have quantum error correction schemes. So as we all know, we are in the NISQ area, so the systems, they still have certain errors, and that's why you need this error correction, because when you start entangling stuff and doing superposition, your error otherwise smears out across the whole system and destroys your whole calculation. That's why we need this error correction. On top of that, we have the programming framework, so like the algorithms as in how we know them, like with the different gates and the different qubits, creating superpositions like flips and so on. This is this programming framework. On top of that, we have the quantum algorithms and applications. And at the very top, we have this user interface, QAAS, and operating system. And that's probably like the highest layer that you can approach it from. Here it says 10 times cost saving for platform providers, 100 times improvement value for end users, and 1000 times improved algorithmic accuracy. The most important customers trust Q-CTRL, and then I guess we have some examples here, students and newcomers, educators, okay, algorithm developers and hardware researchers, and then we find here, I guess, the products or the software products that are relevant for these user groups here. Okay. And then at the end here, or not yet end, but here we see cutting edge research. There are some links to research publications. This is being recorded in early June 2025, and we see here late May 2025 as a date for this paper, so it's really also up to date. There are some very recent publications, and then here you see a team picture with everyone, I guess, at the beach having a lot of fun. Very nice. Some memberships, so probably consortia that they are member of. You see the World Economic Forum, IBM Quantum, Australian Quantum Alliance, and so on. Awards and recognitions, that's also a nice list here. Then we see real-world use cases, which is probably also very interesting. So where is this actually being applied? Let's take a look into this. So we see network rail, accelerating the schedule for quantum enhanced rail, accelerate the usefulness of quantum computing for rail scheduling through custom solution development and performance optimization using FireOpal, 6 times increase in solvable problem size and accelerated timeline for practical quantum advantage by up to 3 years, now estimated for 2025. Okay, so this is an application where they are using their software to optimize the probably train frequency, right? Like making the train network more efficient. And what do we see here? We are pleasantly surprised to see the optimal routing of 26 trains over 18 minutes of real scheduling data for the full station topology being realized on a real quantum device, which otherwise wouldn't have been possible without using Q-CTRL's optimization solver. Okay, very cool. So looks like this is already being usable for trains. Then here we have Q-CTRL themselves delivering quantum advantage to airborne systems. Q-CTRL's Ironstone Opal delivers GPS-free quantum navigation, achieving 94 times better performance than INS in real-world flight and ground vehicle trials. 94 times improvement over the performance of a strategic grade inertial navigation system in real flight tests. Okay, and then we see here from the Chief Executive Officer a statement: we achieved an accuracy in some trials comparable to a sharpshooter hitting a bullseye from 1,000 yards away. But because our quantum assured navigation system allows a vehicle to position itself accurately irrespectively of how far it's traveled, by analogy, that sharpshooter can hit the same bullseye no matter how far away they move from the target. Okay, so it looks like this is a pretty precise measurement, right? Okay, let's take a look at the next one. Improving quantum education outcomes with Black Opal at the University of Hull, UK. Enhancing student engagements and real-world understanding in quantum computing through intuitive and interactive learning with Black Opal. 85% of students reported that Black Opal improved their overall learning outcomes when used alongside with their university syllabus, and would recommend its use in future courses. Then we see here from a senior lecturer in molecular physics and astrochemistry, students who engaged with Black Opal as an active companion resource significantly boosted knowledge, retention, and ultimately understanding. Some of them even engaged further with quantum computing by choosing a final year project in that field. Of course, to comment on this, I find it very nice that they are also going into this education space, that they are helping students to learn about it. Education is one of the key things that we need for this whole quantum revolution. We need to make it accessible, of course, to students and to talent so that we can develop these technologies, but we also need to make it accessible to everyone else. This is what this format is also here for. So this is going to also trigger you if you have an interest in learning about the companies out there, about the problems that quantum technology can solve, and about all of the, let's say, touch points between quantum and the economy side of things. So this format is targeting you if you also want to know the economic side of things. And I'm happy to have you here. And if you want to make sure, by the way, that you don't miss out on another video, make sure to subscribe to this channel. And now let's go to the fourth application. Not Quantique is accelerating the path to useful quantum error correction with Boulder Opal. Not Quantique uses Boulder Opal to design a hardware-efficient QEC protocol for a superconducting system where quantum information is encoded in GKP states. 14% increase in logical qubit lifetime. Given the complexity of the physics at play, being able to perform closed-loop optimization of a few physical motivated parameters of the quantum error correction protocol with Boulder Opal is very useful for us, says the VP of Quantum Hardware at Nord Quantique. Okay, so this is also being used to optimize the hardware or to optimize the quantum systems themselves. And that's this closed loop idea, right? So you take some information, you take some learnings which you get on the software side, and then you kind of mirror them back into the systems to make them perform even better. At least that's how I understand it. Then there are some news and updates below here. There's a field to subscribe to the newsletter, and there are again the labels that we saw above. Now let's take a look at the products, which we've already seen. There's some computing and some navigation here, and then we have the specific product. Let's quickly go through these two main categories, just for the sake of time, so we also still have some time to go into into solutions and resources. Okay. Building the future of quantum computing. Q-CTRL empowers quantum computing with Black Opal for intuitive learning, Fire Opal to boost performance with error suppression, and Boulder Opal to stabilize and scale hardware. Unlock the full potential of quantum with our powerful, easy-to-use solutions. Okay, so as said before, we have this Black Opal, which is the learning platform or the learning system, online learning platform designed to make quantum computing accessible to everyone. So you have different things here, like teach a course, train your team, and learn on your own. Okay, so this is like targeting different groups, right? You have individuals, educators, and enterprises. Then you have something like the probably key points here: world-class content, engaging interactivity, seamless deployment, trusted certifications, real-world applications, and hands-on learning. Very nice. So probably if you're interested in learning more about it, go check it out. I guess there's going to be something also for free, and then maybe something where you can also pay for it. We if you like, we can also check it out in another video together. Just let me know. Then we have FireOpal here. FireOpal delivers full automated error suppression, maximizing the success of quantum algorithms without requiring specialized knowledge. Designed for algorithm developers and quantum vendors, FireOpal ensures reliable performance across quantum processors. So this is targeting quantum processors. Sorry. So what do we see here? Automated error suppression, which is not the same as error correction, right? This is like a mitigation scheme. So if you learn, for example, that your hardware produces a specific error, you can mitigate for that. You can use this closed loop approach to kind of make the system smarter and make sure that you don't accumulate this error. Then we see here best-in-class compiler for optimal performance, algorithmic acceleration, deploy pre-built hardware-optimized solutions for QAOA, VQE, and more. So yeah, we can go into this algorithmic in a separate video. I don't want to go into the details too much. Seamless back-end solutions, and then we have zero configuration. So that makes things fast and easy to use, I guess. Scale quantum hardware with Boulder Opal, then there is something, probably what it looks like here. You see uncalibrated, calibrated, and calibrating. Okay, so this is probably helping you to calibrate the system. Boulder Opal empowers quantum hardware developers with professional solution to design, automate, and scale quantum hardware and controls by minimizing errors, enhancing stability, and replacing manual tasks with intelligent autonomy. Boulder Opal accelerates quantum innovation. So advanced simulation, model-based control, precision characterization, closed-loop optimization, scalable performance, and multimodality support. Okay. So multimodality means, of course, all the different quantum systems that they are supporting, like solid-state systems like superconductors, but also atom-based systems like ion trap. Then we see scalable performance, deliver peak performance every time with autonomous tuned-up solutions. Automate then for closed-loop optimization. I think we talked about that before. Precision characterization, define hardware specifications and environmental noise. You need to measure first the noise before you can optimize for it, right? And then you have in the model-based control, you have standardize and accelerate the creation of infrastructure modules, and then advanced simulation. Okay, that means simulation which also includes the noise that your system is producing, which you also need for this optimization, right? You need to understand first how the system works, and then you can use that to mitigate some errors. We see some labels down here. Besides the quantum computing manufacturers, we also see some probably customers, Lockheed Martin, Airbus, AWS, probably as a cloud provider who's using maybe Q-CTRL, the National Quantum Computing Center, and Deloitte. Okay. Then let's also quickly take a look at the navigation side of things. So enabling the future of quantum navigation. Ironstone Opal revolutionizes quantum sensing for navigation, bringing unprecedented precision to real-world applications. Harness advanced quantum control to detect small signals, eliminate noise, and expand your mission capabilities. Okay, so there we see a couple of labels here. We see the aircraft. This is probably the system that is being used. Let's see if we also find out something about how it actually works. So Einstein Opal delivers GPS-like positioning without GPS through the power of quantum sensing. A totally novel hardware architecture enabled by software ruggedization has finally made quantum assured navigation a commercial reality on land, at sea, and in the air. Discover various solutions tailored to crewed and autonomous platforms. Okay. So we see navigation without GPS, gain a quantum edge, and ruggedize your sensor. Sorry. Do we also see something about how this actually works? Not sure. Make quantum technology useful? No, I think it doesn't say much about that here. So, I mean, we've seen before on other companies' reviews that like there are certain different approaches to do this, right? You can use the gravitation maybe. You could also go with the magnetic properties, with the acceleration. So I think this is not right away clear from here. Maybe if I go on one of these here, but for the sake of time, I think we move on quickly to over here. Maybe we can go here to the quantum sensing part and see what it says. So quantum sensing, that's a bit hard to read here. Okay. Detect the undetectable. Quantum sensors exploit the extreme sensitivity of quantum devices to give you a new way to see the world. This emerging application of quantum technology uses its fragility to work by helping you to detect smaller signals from greater distance and unlock new missions that were never before possible. Okay, bring quantum sensing to the field. What do we see here? Quantum sensors. Then we see here some graphs. Atomic state ratio. Okay, so this is about some atomic states, but I don't really see. Maybe here it says something. Denoising, okay, data processing, but I mean at the end they are providing the software, right? So they're probably also not the responsible ones for how the sensor itself works. Maybe it works with different sensors as well. Let's say it works with different types of sensors, right? Software-defined quantum sensors. Okay. Real-world applications. There we can probably learn a little bit more about that. Gain a strategic advantage with state-of-the-art quantum assured systems. There we see optical magnetometer, gravimeter, and the 3-axis quantum IMU. So, okay, this is about like magnetic, gravitation, and I guess this is acceleration, right? So they are using different types of quantum sensors and they are working. So Q-CTRL is, as per usual, as we saw before, the software side of things, right? They are looking at the software side of things. Okay, what else do we see here in terms of solutions? So we have quantum computing, we talked about that. Sensing, we just saw it. Education, we also saw that. Defense, Earth observation, positioning, navigation, and timing. That we saw also before. Then we have something for users here. Quantum learners, students, researchers, hardware, quantum hardware suppliers, quantum computing developers and enterprises. And then we have industry leaders, artificial intelligence for quantum, biotechnology and pharmaceuticals, cybersecurity, finance, materials and industrial chemistry, and transport and logistics. Okay, let's just pick one of them here in order to not stretch it for too long. I go with quantum hardware suppliers. Okay, wow, that's a nice chandelier here, right? No, it's a cryostat. Okay, quantum hardware suppliers. Bring quantum hardware to market faster with control design and automation software and native error suppression. So I guess this is explaining quantum hardware designers, so companies that create quantum computers, create those chips and the systems, how Q-CTRL is actually delivering added value to their systems, right? Because you see here the hardware, here you see like the software, and that is all being done by Boulder Opal. You see here Q-CTRL domain expertise. So basically Q-CTRL is your interface between providing the hardware and going all the way to the solutions of the problems. Then you see here the software stack and the hardware systems below. So yes, that is like targeting exactly those. And then you see the real world use cases that we looked at before. Okay, very good. Let's also look at one of those industry leaders here. Let's take finance this time. Finance, solutions to the most important problems in quantitative finance can be accelerated by quantum computing. Finding solutions solutions faster than competition is the key to gaining a strategic advantage. Quantum computers have already been used for portfolio optimization and for pricing financial derivatives using approaches that apply to many financial applications. Quantum computing extends the computational toolkit for computational finance, allowing teams to tackle previously intrackable problems at speed. And then we see here some financial organizations that are already using quantum computing, so like Goldman Sachs, JP Morgan, and so on. Gain a competitive advantage with, I think there's a space missing here, quantum technology. We build educational and developer tools that help finance experts take advantage of the quantum opportunity. With our application partners, we can help deliver custom solutions for your needs from education to execution on real quantum computers. And then we see the solutions again here, and we see real-world use cases. Let's quickly check out this one of a Q-CTRL partner. Reducing quantum compute costs 2,500 times with FireOpal. With FireOpal, a financial company was able to run algorithms on more cost-effective hardware systems with achieving results comparable to more premium systems. So 2,500 times reduction in compute cost. Okay, so we wanted to challenge FireOpal's capabilities by running a quite complex, unoptimized circuit. The results were extremely promising. The only comparable results we've seen have come from hardware that is currently too expensive to run extensive tests on. Okay, so looks like there's already some idea of using that here, and it looks like there's some promise also to that, but there is no, let's say, no review here on a specific financial institution that is using it, but we've seen there are some companies which are already using this in the previous examples that we saw. Let's also quickly check out the resources that are provided here. So we see Black Opal again, which is the quantum computing learning platform. Then we have quantum computing fundamentals to get started. And then there are some further resources here like webinars, a glossary, research documentation, advanced topics, beginners topics, and the Black Opal. So there's a lot of things to actually check out and learn here. Probably worth to go and check those things out. Looks like there's a very extensive amount of information here with webinars, courses, and everything, I guess, that you need to know. So definitely go ahead and check it out. As a last point, let's also quickly check out the company part of the website. Let's go to the About Q-CTRL page. It says about Q-CTRL, the most strategic quantum technology company globally. So there's something about company, leadership, board of directors, advisory board, and investors. Let's quickly check out the company part. Pioneers in AI for quantum technology. Manipulating quantum systems without destroying them requires a delicate hand, too delicate for many humans to succeed. At Q-CTRL, we build new forms of AI to access and control the quantum realm. Through our unique technology, pioneering research, and real demonstrations of quantum value, we own the most profound wave of AI technology development. AI for quantum gives us the power to put nature to work for us. It enables a future where new quantum computers power next-generation AI systems in a virtuous cycle, with convergence bringing together multi-trillion-dollar opportunities to change the future of technology. And then we see here this exponential curve, which has AI in chatbots and co-pilots, which is what has happened in the last years. Agentic AI, which is super trendy right now. Then you see AI for physical systems and robotics. So that's what we see taking off right now, right? There's this physics-informed AI on the research side, but you also see robots that are being trained on cloud computers and then act in real life. And here we see as the next step, at least in this graph here, we see AI for quantum and then quantum for AI in this vicious circle that was described before. solving the hardest problems in the field. So now back to the page. Embracing the importance of control was integral to making flight a reality, where the human hand was powerful enough to let us finally slip the slurry bonds of Earth. Of Earth. Fast forward over 100 years, and now AI-powered quantum control software is the linchpin to new emerging industries that can let us transcend the classical world. Okay, then we see the leadership team here and the board of directors, the advisory board, and then we have the list of the investors down here. Very good. I think that's already it for this company. I hope you liked it. As always, if you enjoyed this video, then please make sure to subscribe to the channel and don't forget to always stay hydrated. See you in the next one. Bye bye.